Namaste bachcho. Welcome back in today's class. Today we'll discuss about how can we obtain different gases from air. In previous class we have discussed regarding fractional distillation. Okay, and this separation of gases from air is an application of fractional distillation. Okay. There are some steps which are required, and it is shown here in the flow diagram. These steps are required in separation of different components of air, that is different gases from air. First one is compress and by increasing pressure and decreasing temperature. First of all, we compress air and simultaneously we cool air to decrease temperature. Okay. Then we get liquid air. Liquid air is allowed to warm up slowly in fractional distillation column and at different height in fractional distillation column, different components of air are obtained. Okay. We have discussed earlier that fractional distillation working on difference in boiling temperature of different components of a mixture. Here air is a mixture which has different gases like oxygen, argon and nitrogen, and these three gases also have different boiling temperature. That is, oxygen has -183 degrees centigrade, argon has boiling temperature -186 degrees centigrade, and nitrogen has boiling temperature -196 degrees centigrade. Means this difference in boiling temperature help us to separate the different component of air. Now we will try to understand with the help of diagram how it works. Okay, let us see the diagram. Next page. See, this is the diagram in which we will better understand the separation of components of air. See, first of all, air is passed through filter where the solid impurities which are present in air are separated. Okay. Then air is put under pressure. When air is compressed in this place, see, they are the apparatus to compress air. Due to compression, the air becomes heated. Now the question arises, why air becomes heated on compression? See what happens when we heat air. The molecules of air collide with each other randomly, and the collision become more and more faster than the usual condition, and they produce more energy in the form of heat, and that's why the air becomes hotter. Now here we see the hot air is passed through this pipe, and in this column or in this part of apparatus, air is become cold. See what is done here. Freezing cold water is passed through a coiled tube, this container, and hence the air become cool. Now cold compressed air is passed through this pipe into a separator. See, it is a separator where cool air is passed through. Means from this portion, the cool air passes in this separator where carbon dioxide gas is separated in the form of dry ice. You know, when carbon dioxide gas is cooled, it converts into dry ice. So from this separator, carbon dioxide gas is separated to this opening and it is in the form of solid, that is in the form of dry ice. Okay. Now liquid air is passed into the fractional distillation column. It is a fractional distillation column here. In this one is a fractional distillation column, this one, and through the expansion jet, air is passed into this column where it is slowly heated. Means temperature is very slowly being risen up in this fractionating column. See, there are three openings here at different height. This first one is here at the lower level, then argon and then nitrogen. As we have discussed earlier in the previous topic, that in fractionating column there are different openings for different boiling temperatures. See here, the component which has least boiling point, that will boil first. Okay, as I said that the heating will be very slowly. So first the all nitrogen part will boil off and the vapors will rise up and they will pass through this opening. Okay, then after nitrogen, argon will boil out. Okay, and it will pass through this opening. Okay, and at last the oxygen gas will boil out because it has the highest boiling point of these three gases. Means amongst nitrogen, argon and oxygen has the highest boiling point, so it will come out at last. Okay, so from here the oxygen will come out, and in this way with the application of fractional distillation process, we can separate the different components of air. Okay, so it is a application of fractional distillation process where we can separate the different components of gases. It is because of the difference in boiling temperature of the different components of air. Okay, this is about the process of. See, once again we will see here the difference in boiling temperature. As I have discussed earlier, that the boiling point of nitrogen is -106. It is the least boiling point among these three gases. The nitrogen has the least boiling point, so it will boil up first and then argon and then oxygen. Okay, so this difference, and also you will see the difference is less than 25 degrees centigrade. Okay, so we have discussed earlier that the component which have very less difference in their boiling temperature, that will be only separated with the help of fractional distillation process. Okay. Okay, thank you for today's. Next we will discuss about the next topic.